Good morning. Good morning. My name is Muhammad Denimi Rosli. Today I'm going to share my case study on installing chill water fan coil units in tight and resistant space. I really wanted to look at how we manage the partial blending, the logistic and safety side of things. This project was prepared for TS Dr. Muhammad Ashril bin Saudin. Okay, on second slide is a project overview and core challenges. The main goal of my study is to evaluate how to handle the tight spaces and logistical limits during the FCU installation safely. I focus on congested shading void right near busy public area like escalator. The biggest issue I found were the severe lack of space, concrete beam getting in the way, and the unit clashing with other services already up there, like sprinkle water, like fire sprinkle and cable tray. On second slide is the FTU dimension and space requirement. Just to give you a quick background, an FTU is a local cooling device that use a fan and a heat exchange coil. But to actually get it working, I have to make sure it hits some strict clearance rules. First, the ductwork needs at least a foot of clear space. The piping needs to at least 6 inches of the room for chill water lines. And for the drain, I have to maintain a straight slope of 1 per 8 to 1 per 4 inch per foot. If that slope is it there, the condensation will leak and ruin the ceiling below. On second slide is about defining confined spaces and atmosphere hazard. Because these shielding pockets are so small, they often fall under the OSHA definition of a confined space, meaning they have a tight entry and exit point are meant for people to stay in continuously, but are just big enough to climb into and work. The environment introduced serious atmosphere hazard. Oxygen deficiency is a big one. Anything 90.5% is a dangerous and cause hypoxia. I also have I also have to worry about a toxic and flammable gas buildup like a refrigerant leak, carbon monoxide, or hydrogen sulfide. Second slide is about installation risk profile and test control. When you look at the physical job itself, the safety risks are pretty high across the board. Carbon monoxide poisoning makes up about 25% of the risk profile. Fall from height are 22%. Electrical shock is about 21%, and refrigerant exposure is 90%, and manual handling around about 40%. To handle this test safely, here what I'm putting in place for drilling and coring. Worker must use dust vacuum and perform structural scan. For electrical work, I enforce a strict lockout or take-out process. And for heavy pipes, I require mechanical jets and team lift so nobody can get hurt. Six is hierarchy of control and conclusion. Here the picture of PPE and gas detector tool photo. To keep things safe, I looked at the classic hierarchy of control. For engineering, I use ventilation fans, mechanical lift, and what is it called? Guardrails. On the administrative side, I rely on permit to work system and continuous gas monitoring. And for PPE, workers have to wear harness, aspirator, hard hat, and non-conductive glove. To wrap this up, a successful job really comes down to planning early with other trades, sticking strictly to safety permits, and actively stopping risks before they happen. And yeah, thank you for listening.